Hello everyone and welcome back to Reverse Engineering Learning. So these are going to be a few challenges from Pico CTF 2024. Specifically we're going to go over the heap challenges, so 0 through to 3. So heap 0 asks, are overflows just a stack concern? And we're given a binary and a source and a remote. So let's have a look at heap 0. So the challenge itself, we are presented with a menu. We have a few options. Maybe we'll open it up alongside. So let's run the challenge. So welcome to heap 0, and it presents us with the heap state, and we can see there's two pointers that point to strings and memory. So we've got Pico and Bico, and we can do a few things here. We can print the heap, write to buffer, print the safe variable, and then print the flag as well. So we're obviously interested in the flag. So let's have a look at print flag. So that is down here, which is number 4 print flag. It's just to check this win condition. So in order to satisfy the win condition, we have to say that the safe variable is not Bico. So that's this one here. So we're going to have to do some sort of like buffer overflow, but just on the heap. And we can see that we are allowed to write to a buffer, which is, let's have a look, input data, which gets put into where the memory of Pico. So there's two sets of memory that have been given to us by malloc. There's this Pico and the Bico, and we're allowed to write to this one here, Pico. So what we have to do is we can see that these addresses are contiguous. So B0 and then D0. So we're going to have to write something long enough so that it overflows into the heap segment, or that area of memory that's here. And so this one's quite simple. We just have to override it, and we don't really care about what it is. So the solve for this challenge is to, we enter our choice where we go selection 2, where we write to buffer, and we just write a string long enough that's the difference between D0 and B0 plus 1. So that's the original difference, and then we just overwrite one of these letters, and then we send that, and then we ask it to check the flag variable to see if it's overwritten. So let's quit this and we can do the solve. And here we go. We have our first heap overflow. Great. Alright, so for heap 1, it's can you control your overflow? And we're also given again the binary and the source to this one. And this one looks pretty much almost identical to heap 0. So we have our Pico and Bico, and we have a few of the same similar options to print the heap, write to it, and try print the flag. And so under the hood, this challenge is pretty much almost identical to the first one, except for the fact that the win condition just has to make sure that it's the string comparison doesn't check if it's changed, but it checks that it matches the word Pico. So we're going to have to change Bico to be Pico in order for it to be satisfied. So it's going to be very much similar to the same thing. We look at the offset between the two heap allocations, and we overflow from one into the other, but we just have to make sure we get the right alignment to put in the word Pico. And so the remote solve is very much similar again. We know the right amount of offset between them, and then all we have to enter is that offset size and then Pico, and then just ask it to check. So we can do the same thing. We do Python 3 and then solve, and we'll connect to the remote. And there we go. That's our second heap overflow. Alright, and so for heap number 2, we're asked, can you handle function pointers? Similarly, given binary and a source, and an application that looks very similar to the other ones, where we get told, I have a function I sometimes like to call it, maybe you should change it. And so we print the heap, write to buffer, print X, or print the flag. If we go and have a look at the source code for this challenge, we can see some of the similar functions. There's a win one, there's a check win one, which looks a little strange, and then the usual shenanigans. This here is a function pointer, but we get to decide what's executed. It looks a little scary here, but inside Ghidra it looks a little better, where we can see that whatever X points to is executed as a function pointer. So what does that mean? That means we have to somehow overwrite X, which is this one here, to point to the win function. And we can't just use, for example, the word win, because it doesn't know what that is. We actually have to use one of the addresses in memory. Alrighty, so if we look in Ghidra, we can see here the rough area of the win function of the addresses that we'd like to see. 0, 0, A0, A1, A5, things like that. So we can actually use some tools to help us in Pwn tools from the Python library to say, okay, well, we know that we're going to have some sort of heap overflow. So I tried before with cyclic and found it was at this IAAA is where we start overflowing into the other heap. So we have our offset. We're going to send data to the buffer that's the size of our offset, and then we're also going to send it the address of the win function. So elf.symbols, and then we can give it the name of the function that we want. So I have it running over here in this other window here, and it's at a breakpoint. The breakpoint's at main 390, which is just before we make the call. It's at this part here, so this instruction. So we can have a look here. We are at the function, we're at the instruction that's call RCX. So we can see here, call RCX, it's this instruction here. So we're about to jump to our overflow. So we can see that if we have a look at RCX in that register, is this address here, which points to the first line in the win function. So 4011A0, and if we disassemble win, we can see here this is the start, that instruction that it points to. Alright, and then we can continue and follow it. So we can see here we're in the next instruction now after we followed it. But we don't really care too much. We can just continue, and it terminates because it gets a seg fault. But we can actually run this against the remote. So let's fire that up. So we can just go and comment this out. So we're not running it against the local binary, but we're running it against a remote one that's running on Pico CTF. So let's quit out of this, exit, and we'll run the solve again. But this time it's going to run on the remote binary. And we can see here, we got the flag. Perfect. And now finally for heap number 3. So this program mishandles memory. Can you exploit it to get the flag given the source and the binary? And the same stuff as the other challenges. There's a few things to note that when this application starts, we do get told about a little message. So let's check that. We get told freed but still in use. Now memory untracked. Do you smell the bug? So that's giving us a sort of a hint here. And we have a few options. We can print the heap. We can allocate an object, print X flag, check for the win, or free X. Let's have a look at our win condition. So in this challenge, we have to go and check. We have to change the value of X flag to be Pico, and we can see that X is an object here and it's a type of struct. The key for this challenge is that it's a bit dangerous that we have the ability to free this X value, because that's what gets used to check if we win. So it checks X and then dereferences flag. So right now, it's fine. It's valid. It's in memory. It's being allocated to the heap. But what happens if we free it? So let's go have a look and free X. Let's try print it. Let's print X.flag again. So it still has something there. X is still equal to B. So it's still in memory. It's still being pointed to in memory. So the dangerous part about that is if we ask to allocate a new object, we may have the memory that has just been freed. And so if we still have a pointer that points to that specific memory address to check the flag, and we insert a new object that satisfies this condition, then it will work. So we go over here. So what we do is, this is our payload here, so a certain amount of characters to fill up a buffer, and then our payload we want pico, and so this is the size of the struct. So if we look back over here, it's about 35 bytes. So it's the size. We free X, tell it that we're going to make a new struct, and we allocate a size and the payload. And so when it makes the malloc call, so here when we allocate a new object, the pointer that we get may be the one that we just freed before in X. And so that means X dereference flag actually points to our new object that we created. So we can launch an instance similarly and run it against the remote. So get the port number here, place it in, and let's run it. So there we go. We can see the steps here. We decide to free X, allocate a new object, send the payload, then ask it to check. And we get the uwin followed by the flag. Perfect. Alrighty. Thank you, and that's been PicoCTF 2024 Heap Challenges.